So in today's video, I'm going to discuss about that GATE physics paper for 2026, and this is the question based on the mix-up of analog and digital circuit. But more precisely, I have taken this as an analog circuit as a subject. Under that, op-amp is the core part of this circuit. So that is the reason I have taken the topic as a op-amp. So first of all, we have to understand about the question, and after that, I'll give you the detailed analysis as well as detailed solution for this question part. So the question here, it has given the output signal as a current ID of a reverse bias with a voltage VV photodiode on which light is incident is fed to an amplifier. See figure full stop. The output voltage is digitized by a 10-bit analog to digital converter, which is called in the short form as a ADC, which has a reference voltage of 5 volt full stop. The smallest current ID, which can be measured by the circuit in nano amperes, under bracket round off to 1 decimal place, is fill in the blank. And this is the question they had asked as a numerical answer type for 2 marks. So now if you see this figure, what it is doing, that this is the photodiode, this is the photodiode given here. So what it is doing, like as per the light is incidenting on this photodiode, it is reverse bias. So corresponding to that light intensity, their corresponding current will be flowing through this, and that is going to be converted here in terms of voltage, and that voltage will be changed into analog to digital format by this ADC. So here in this question, what they had asked? They had asked about that smallest current ID which can be measured by the circuit in nano ampere. So here, if we will leave that at the beginning it is 000, but after then how the reading will start, how the conversion will start from 0 volt to certain voltage. So here the minimum voltage after 0, what it will happen, it will first convert that resolution part, that by the resolution amount only, with the each part it is going to be incremented. So here first of all we need to calculate the resolution of this ADC. So just for the example, I am assuming here resolution is, just I am assuming as a notation as a K. So this resolution is defined here as a reference voltage divided by 2 to the power n minus 1, where VR is called the reference voltage of this ADC and n is the number of bits of this ADC, which is mentioned in the question itself as a 10-bit is the number of bits, and VR is the reference voltage already mentioned here as a 5 volt. So if you substitute here, it is here 5 volt divided by 2 to the power n is 10. So 2 to the power n minus 1, it means it is 5 divided by 2 to the power 10, as we know that it is very familiar number. So that is called 1024. So minus 1, it will become here as a 1023 volt. It means if we calculate this, that values will be very, very smaller. So we can represent this as a 4.88 millivolt. 4.88 millivolt. So now this much of the smallest voltage can be converted by this ADC. It means as long as voltage is smaller, then corresponding to their current will be also smaller. So at this resolution voltage, which is going to be converted into digital by this ADC, if we are able to find out their corresponding current from this circuit, so that is called their minimum current. So here this ID, how we can calculate, if you see that as per the virtual short, if this is 0 volt as an amplifier property and as per the virtual short of this op-amp, so here if this is 0 volt, then this will be also 0 volt. So this ID current, whatever is reaching to this node point, there is no current passing through this op-amp in ideal case. So this current is passing through this resistor as a RF, and that is by this way we can apply the KCL at this point, and we can calculate corresponding to the minimum voltage, we can calculate their minimum current. So here this ID is given 0 minus V out, because for this resistor RF, their two terminal voltage are what? One terminal is at 0 volt, another terminal is at V out. So 0 minus V out divide by R. So more precisely, it should be mentioned in the question and the magnitude of the smallest current, because diode is reverse bias. It means current direction will be like this only. It will be like this only, and this current is passing through this. So by using this only, we are doing the calculation. So here this ID is equal to 0 minus V out divided by R. So this V out is coming here as a 0 minus 4.88 millivolt. It means we can write here 10 raised to minus 3 divide by this R, as per this one it is basically RF only. So here it is 100 kilo ohm. It means we can write it here 100 into 10 raised to 3 ohm. So as we know that what will happen, this 10 to the power 5 will goes to the numerator part, so that will become 10 raised to minus 8 volt. It means we need to volt by ohm, it will become that ampere. So we need to represent this in terms of nano ampere. It means what I am trying to say here, this will become 4.88 into 10 raised to minus 8 ampere, because this volt by ohm is ampere, and here this minus sign definitely it will come here. But as per the answer sheet or key answer provided by this GATE committee, it has given the answer in terms of positive only. It means they consider only their magnitude. So now if you want to change this in terms of nano ampere, so this will become here as a 48.8 nano ampere. 48.8 nano ampere is the final answer coming for this. So that final answer will be, final answer is 48.8. Simply nano ampere already mentioned in the question itself. It means the numerical value will be 48.8. And how much value it has provided by this GATE team? It is given by 47.5 to 50. So this magnitude is coming under this range. It means 48.8 is the valid answer, because in the question itself it has given only one decimal point. So 48.8 is the final answer for this question. And the majorly part, if we know about that, how to calculate this resolution, if you are able to correlate that resolution is the minimum voltage apart from 0 to converted by this analog to digital, and if this is, as like if you see it here, this RF is a constant value here, it is not going to change. It means ID is directly depending upon that V output. So as long as this output voltage will change, their ID is going to be changed. So if V out is minimum, ID will be minimum. So that we got it here. As a 48.8 nano ampere is the final answer for this question. I hope you enjoyed this solution and understand this analysis also, their solution also. Thank you very much. फिर मिलेंगे अगले वीडियो में अगले क्वेश्चन के सॉल्यूशन के साथ. थैंक यू.